Welcome to our presentation. The topic of our PowerPoint presentation is radio pill and Manu Satya. Next slide, please. What is a radio pill? It is an ingestible wireless capsule for GI monitoring. Smart pill technology that monitors gastrointestinal tract parameters including pH, temperature, pressure, and conductivity. Its key components are that it is a miniaturized sensor, microchip, wireless transmitter, and compact batteries, all packed into a vitamin-sized capsule. It was first introduced in 1957 for biomedical telemetry, evolved from basic radio transmitter to today's advanced digital sensor systems. Current versions integrate ESIG for sophisticated data processing and real-time monitoring. It provides painless, non-invasive inspection of the entire digestive tract, eliminating the need for uncomfortable traditional endoscopy procedures. Its history and evolution in more depth is the idea of ingestible sensors started in the 1950s when scientists first imagined using miniaturized electronics for internal monitoring. By the 1980s, prototypes of swallowable capsules were created. In the 2000s, the US FDA approved capsule endoscopy for medical use. Today, radio pills its basic concept is when a patient swallows the capsule, it naturally moves to the digestive system, expresses fluids. First, the patient swallows, takes the capsule with water. The capsule then travels to the stomach and intestines. Sensors, the cameras that senses capsule images and readings. The data is then wirelessly transmitted to an external receiver. And then the final step is the diagnosis. Doctors analyze data for accurate treatment.
वो दिख रहा है व्हाट्सएप
Now I will continue with the instrumentation block diagram, which consists of sensors. Then it goes to controller, then the memory, where programmable logic and operations takes place, and then it goes to the power supply. Next slide. It consists of sensors. Sensors can be of different types, like pH sensor, which measures the acidity and the alkalinity. Then seconds comes the temperature sensor, which monitors the temperature. Third is the pressure sensor, and the last is mini cameras, which captures the real-time images inside the gastrointestinal tract of our body. Now the second component is the microcontroller or the ASIC. It collects the signals from the sensor and the cameras from inside of the body and performs basic programming and functioning. Then we have RF transmitter plus the antenna which sends data wirelessly to the external receiver. Then comes the power supply or the battery. This compact biocompatible battery, which is biocompatible, does not react with the internal parts of our body, and it is safe for human beings. Then the last is external receiver, which transmits data, sends it to the computer or the monitor so that the doctor can analyze and checks the report of the patient. Next slide. Now comes the internal structure of the radio pill. It consists of the outer silicon coat. The outer silicon coat in the radio pill acts as a semiconductor which substrates the supports and integrates micro sensors, enabling precise physiological measures inside the body. It consists of communication coils, temperature sensing crystals, and the battery. Next slide. Now we'll discuss about cross section of a capsule. It consists of cameras and LEDs which provide light and imaging of gastrointestinal tract or the small intestine of the human body. Then comes the sensor unit which includes pH, temperature, pressures, etc. Then we have battery which are made up of micro lithium ion for providing power so that the cameras can act inside the gastrointestinal tract. And last is the transmitter and the antenna, which is wireless and it is used. We have the wireless video transmitter between the receiver and the transmitter. Next slide. Working principle of a radio pill. First step is swallowing. Patient injects the capsule with the water. Then it naturally moves through the gastrointestinal tract, and then data is collected through the sensors, which measures physiological parameters, and the camera captures images. Then we place on the monitor and can be read by the doctor for analysis. Next slide. Now we have some mathematical relations occurring inside the radio pill. First relation is the RF communication frequency, which is F is equals to C by lambda, where C is the speed of the light and lambda here is the wavelength. Then comes the second equation, which is of power consumption, which is P is equals to V into I. Here P is the voltage, P is the power, V is the voltage, and I is the current of the battery. Last is the data rate. Data rate is equals to n by t, where n is the number of bits transmitted divided by time. Now my friend will continue further.
Here we see the important biomedical application, which is capsule endoscopy. Capsule endoscopy is used for diagnosis of ulcers. Captures thousands of images from gastrointestinal tract. That image is transmitted wirelessly to recorder. There are other applications are there, which is pH and pressure monitoring. It helps diagnose conditions like GERD, mortality disorder by measuring pH levels and pressure in the gastrointestinal tract. Core body temperature monitoring, which is used for athletes and the soldiers to track body temperatures in real time, ensuring the safety during extreme conditions. Targeted drug delivery. This is an exciting area of ongoing research where capsules could deliver medications precisely to affected area, minimize side effects. And the advantages of capsule endoscopy, which is it is non-invasive and painless, it making it a comfortable option for patients, and it provides real-time monitoring, allowing doctors to get immediate insights. The images are highly accurate, aiding the accurate diagnosis. Overall, it is a patient procedures. Limitations of capsule endoscopy: expensive, and it has limited battery life about 8 to 12 hours, and it is not steerable once swallowed, and there is a risk of retention. In rare case, the capsule gets stuck, requiring medical intervention.
Hello everyone, I am Syed Asad Nehal Ahmed and I am going to tell you about the recent advancements in the radio field industry. Radio field industry advancement include digital pill, which has smart medication tracking. FDA approved digital pills like Abilify MySite that can confirm when patients can take their medication, helping doctors ensure treatment compliance. Advanced health monitoring. New ingestible sensors can detect gases in your digestive system and help last is the rapid technology growth. Research shows sensor technology in pills has expanded significantly with many new patents filed in 2022 alone. Next slide. Next slide. Edible electronics and feature tech. It includes tiny edible robots that can travel to your body, deliver medicine exactly where it's needed, and help doctors diagnose problems from the inside. Safer materials that last longer in the human body. These new biocompatible substances can work for days or weeks without causing harm. Smart AI integration that analyzes data in real time, such as instantly detecting if someone has taken a dangerous overdose and alerting emergency services. Last is the multiple sensors are working together to create a complete picture of your health, combining temperature, pH, and pressure readings for comprehensive monitoring. Thank you.
Hello everyone, my name is Omar Heri. I will be discussing about some important questions of this topic. So the first question is what is radio pill? The second one is name to biomedical application. Third is what is the main limitation of capsule endoscopy. Fourth is how can AI improve capsule usage? The fifth is what formula gives RF frequency. Next slide. So these are the answers of the question. For the first question, an ingestible wireless capsule with the sensors that monitors gastrointestinal tract parameters like pH, temperature, and pressure. For the second question, name to biomedical application, GI tract diseases, diagnosis, and targeted monitoring. Third question, what is the main limitation of capsule endoscopy? Limitation battery life, typically 8 to 12 hours, may not cover complete improve cash usage, real-time data analysis of the detection abnormalities, automated diagnosis alert. And the fifth question is what formula gives RF frequency? F is equal to C by lambda. So I'll give the summary of presentation. The definition of radio pill is ingestible capsule with the sensors plus transmitters. So working is it is all out, then it moves to GI tract and it collect data or images, transmit wirelessly, and then it is analyzed by doctors. Instrumentation, sensors, camera, battery, transmitter, external receiver, mathematical relations, RF frequency, power consumption, data rate. The applications are capsule endoscopy, pH monitoring, drug delivery. Advancement and future. AI, IoT, magnetic navigation, nanotechnology capsules. Next slide. So these are the references we took for this presentation topic.